So this is a cubic equation. It either has a max and a min. It either looks like this or looks like this. I don't. You can figure out which one using your table function if you really have to. You do a quick sketch of it, couldn't you? Now, here's what we're going to do. Yeah, it's called the factor theorem. You're going to bring the 3 to the other side. And you're going to, yeah. Is there anything difficult about this question? Do you want me to skip it? We have it done. Okay. For people at home, the lads in here are saying this is too easy. I think we did it in a test. There's a hole in the system. But either way, we'll just fly through this. It won't take us long. Take them away, and as Colin says, one less question in their papers. What goes here then? Yeah, it's always x squared x and regular number, isn't it? It's a quadratic, yeah. You multiply it out and you get minus 1x squared minus 3x. Change the signs. Plus and plus. Minus 1x minus 3. I actually did this recently. I think I did it with my 5th years. This is in the 5th year exam, actually. So this was in the 5th year exam I used recently. So that's it there, yeah. And then we're going to solve what the roots are on top. So you're going to do the, I'm just going to factorize it really quickly. It's going to be, there's not many options, is there? It's just the number, it's -1, so it's going to be -1 and 1. You can do the minus b formula if you're at home. He knows I'm talking to him. I bet he looks at the videos. My biggest fan. X equal to half and. How would you check that answer? You could sub it in, or you could put your full table function in and go up and step at 0.5 and you'll see where all the intercepts are. No hassle. Okay, now part B. Find the maximum and minimum point of the function. Oh god, this is an easy question. Okay, what's the original equation again? Yeah. Yeah. Okay, now here's what we're going to do. Maximum and minimum point are basically where the slope equals 0. And in differentiation, the first derivative is the slope, isn't it? So what do we get here then? Then x. And that the slope has to equal 0, so the first derivative equals 0. Divide across by 2, maybe. Make it slightly easier, maybe not. Yeah, it does. Right. I'm just going to be a bit slow. I'm not going to do it the long way, just because I'm saving myself some time here. I'm going to call that +2 and that one. -1. I'm going to get x equals -2. 3x equals 1, x equals. Now the problem here is that it's looking for the point. You get what I'm saying? So I need the y value as well. So how do you get the y value? Yeah, so if you could do that on your calculator, that'd be really useful. Into the original y equation. So it's going to be done twice like this. It's going to be that's one of them. And then if you do the third one, Colin, he'll do 2 minus 2, you do 1/3. It just means we can go faster. -2 and 9. Okay. So -2 and 9 for one of them. Put it as a fraction. Minus 100 over 27. Now, which one do you think is automatically the maximum? Whichever one has the higher y value. So green one is maximum, and blue one is, and yellow one is. There's also something called the second derivative test, isn't there? If it's bigger than 0, it's the min, and it's smaller than 0, it's. But does it say to examine the nature of the roots? So you don't need the second derivative test. Is that right? Right. Now, is that the end of the question? Good. F of x plus a, where a is a constant, has only one real root. Find the values of a. I must show you this. Okay, what's the original function again? So it's so yeah, I have an idea. Okay, ready for this? We're going to take out GeoGebra as well, just to show you what exactly is going on. Okay. So we're going to take out a bit of GeoGebra. Let's look at this. This is our function here. Everybody see it? Okay. Now I'm going to draw something similar in a second, and I'm going to show you what we're looking to do. How many roots does it have currently? Because I think I took it down wrong. I think we took it down wrong, lads. What did we say it was? Plus 5x squared minus 4x minus 3? Plus 5x. See how I know it was wrong? I meant to have 3 roots, no? Because we already solved this for 3 roots, didn't we? There we go. That's more like it. Now, so get this, all right? Would you agree it's a max followed by a min? Now look at this. Look what happens if I just start messing around with this slightly. Right? It's a max followed by a min, wasn't it? Okay. So imagine this. Max, min, done. Look what happens when I raise it. Still has 3, still has 3, still has 3. It has 2. That makes sense? And anything above that, it has 1. So what I'm thinking about doing is, if I can figure out a way to raise the minimum, I want to raise the minimum above the x-axis. Do you get what I'm saying? If I grab this minimum, what's the minimum point again? Minus 2 and, I don't know, what was it? What was the fraction again? You gave it to me a minute ago. I think I might have it here, is it? Minus 100 over. Okay, just better be careful, that's right now. Minus 100 over, which is roughly 3.7, isn't it? And I think, looking at our graph, I think if I was to zoom in on that, here we go, I'm going to zoom in on it. It's not 4, is it? It is actually 3.7. So you are correct. All right. Now here's what's happening. Okay. It says that A is a constant, doesn't it? A is a constant number. And find the range of possible values of A. Well, look at this. For argument's sake, if this picture was, if that was minus 2 minus 4, guess what happens when I add on 4? When I add on 4, I bring the whole line up. I bring up the whole line up 4, don't I? And then I'd only have 2 roots. But then if I do it above 4, it will be 1 root. But it isn't 4, is it? What did we say it was again? 100 over. So what I'm going to do is I'm going to add a number bigger than 100 over 27, because that will send the minimum point above the x-axis, and therefore it'll only have 2 roots. You actually got that? That's delivered all right? You understand it? Cool. So the answer is the range of values. Any a value above 100 over 27.